Hi, everybody. Okay, so let's talk about the water cycle. So we talked about the carbon cycle in the last video. Now we're going to talk about the water cycle. And then we're going to finish up our unit with a talk about green energy and ways to help conserve and save the planet. Okay? So the signs of the water cycle. There are three states of water. The first is solid, which is like ice. Then the second is liquid, which is like water, and gas, which is the water vapor version. Okay, so we don't see it, but we can kind of see like water's in the air, basically. Okay, so when water is in a solid, when it's ice, the molecules are really packed together. They're vibrating very slowly. Water doesn't have much energy when it's in the ice state. Okay, when it starts getting like warmer, it gets to the liquid state, right? That's because the molecules are vibrating more, like they're vibrating a lot faster. Not completely fast, but they're like at a medium speed, which means that we see water kind of like loosely packed. The molecules are sliding past each other, so that's why water's all fluid and stuff like that. And then when we get to the gas form, molecules are spread apart and they're moving really fast. And so they're moving so fast that we don't actually see it. Okay? All right, so how does water change state? Okay, we change state of water by adding or removing heat energy. Okay, so when we add energy, that is, we add heat, we make the molecules move faster. Therefore, we go from ice to liquid, solid, liquid to gas. Right? If we remove energy, that is taking our energy out. Right? We're cooling it down. We go from gas to liquid to solid. Okay, so is energy added or removed? So when ice is melting, energy is added. That means we've added heat to it, and therefore the ice is melting. When water is freezing, energy is removed. We're taking out heat, okay, removing heat, so that means that the water begins to freeze. When water is boiling, we add energy to it. We add heat so that the water begins to boil. Okay. So where does this energy come from to change the state that water is in? Well, in nature, this process is driven by the sun and the energy that we get from the sun. So, we have water in its liquid form. Heat from the sun evaporates that water, goes up into the air. Eventually, the water begins to cool, and therefore it condenses. So energy is removed from it, and it begins to condense. And then when more energy is removed from it, that water vapor turns into precipitation or rain, and it falls to the earth. And then it collects in the ocean and then goes back to evaporation. So the water cycle is water's being constantly cycled between the atmosphere, the ocean, and land. The cycling is a very important process. It helps sustain life on Earth. It helps recycle water, all of that stuff. Each part of the cycle drives the other parts. So evaporation is the process where a liquid, in this case water, changes from its liquid state to a gaseous state. So we go from liquid in the ocean or a river or whatever, a body of water, and it starts, heat is added, so the water begins to evaporate. It becomes like little gas molecules, and it goes up into the air. Evaporation, so some of the water in oceans and freshwater bodies, like lakes and rivers, is warmed by the sun and evaporates. During this process of evaporation, impurities in the water are left behind. So that means bad stuff in the water is left behind. Okay, because if you have a bunch of salt water and you stick it out in the sun, only the water is going to evaporate. When it's done with it, the salt remains. Like the salt is left behind because salt is not something that gets evaporated. It's just the water. Okay, so as a result, the water that goes into our atmosphere is cleaner than it was on Earth. Condensation is the opposite of evaporation. So this is when a gas is changed into a liquid. When water droplets are formed from condensation, they're really small. Okay, so we get like small, tiny little drops, and they remain suspended in the atmosphere because, they're so small they barely weigh anything, and therefore they can hang out in the air. Okay, these millions of droplets are suspended in water form, in basically in clouds. okay, from clouds. In the clouds in the sky or fog at the ground level, that those two things can hold like water suspended in the air. Now, when the temperature and the atmospheric pressure are right, those small water droplets in clouds form larger droplets. So basically, the temperature usually has to get a bit colder, and the air pressure has to be just right for those water molecules to begin to bond. And when they bond with each other, they make larger water droplets. And eventually they get so big that they can't hang out in the air anymore. Gravity starts to take hold and they start to fall. And that's where we get raindrops, or what we call precipitation. Okay. So once that water hits the earth, okay, it runs off the surface of the land. Sometimes it sinks through, like in LA, for example, when we get like very little rain, the water just hits the ground and then it soaks in the ground and that's it, right? But sometimes too much water is hitting the ground, or the ground can't handle the water load, so it begins to run off or slide off the ground. And what happens is it runs off the surface and it flows into downhill into streams, rivers, ponds, and lakes. So the water just sort of goes whoop, down the hill and goes into some kind of body of water. Now, these small streams flow into larger streams and then into rivers, and then eventually the water flows to the ocean. So that's the idea. That's how water collects in the ocean. It gets there by way of rivers and streams and all that kind of stuff. So surface runoff is an important part of the water cycle because through surface runoff, much of the water returns again to the oceans. Okay, and that's where most of the evaporation occurs. So that's where the water needs to go. Now, percolation is something you may not have heard of. Percolation, or otherwise known as infiltration, is a process where the rainwater soaks into the ground. Okay, so this is when water hits the ground and instead of running off, it soaks into the ground, right? Now, this is how like grass gets really green and all that kind of stuff because plants get water, yay! But sometimes that water soaks deep into the ground and goes through the soil and into rock layers that are underneath that soil. Okay, and what it does is this water kind of makes its way through the rock. Some of it ends up at the surface again. Ultimately, gets to the surface, like in springs or low spots downhill. It just sort of ends up collecting and stuff like that. But mainly, what I want to talk about is this infiltration into the rock. Okay, what happens is when it gets into the rock and it goes all the way down, it goes down to what we call groundwater. I'm going to talk about in a sec. I just want to talk about this picture where it basically says that when rain is landing on like a mountain or a hill, you have a lot of runoff because the water is like sliding down thanks to gravity. It doesn't have time to soak into the ground as much. Okay, but like in gentle terrain, where it's sort of just a light slope or like a flat ground, then the water has time to seep into the ground, so we get a lot of runoff. Less runoff, more infiltration. Okay, so some of the water percolates underground and is called groundwater. So this is where water makes its way through rock and soil and gets into like these underwater caverns where there's water. Okay, and as the water moves through this soil and through the rock layers, many of the impurities in water are filtered out. This is like a natural filtering process. It helps clean our water. That's why, we're not just drinking like piss all the time. It's like in nature before we had like plumbing systems and all that kind of stuff. Water would filter through the rock layers and stuff like that, and it would remove the impurities until it ended up in the groundwater, and it would get like really clean water that would then end up in the streams and end up in places where animals could drink it. So water moves into these caves formed by carbonation. Carbonation is like the fizzy stuff that you get in soda. Okay, that's like carbonation. It basically creates air pockets. And it, like water, formed these things called karst features. It's not that important. We don't need to know about it. Just know that you have these caves that are formed underground. These like little air pockets where water can collect. Okay, one final process that's really important to the cycle is transpiration. So as plants absorb the water from the soil, the water moves from the roots to the stems to the leaves, okay? And then water can evaporate out through the leaves. Because sunlight, plants are using the water to make sugar and all that kind of stuff, and they produce water vapor. Yay. Okay. The process of evaporation through plant leaves is called transpiration. In large forests, an enormous amount of water will transpire through the leaves. So yes, that happens, like in the rainforest. And then we're back to evaporation because water has now evaporated, it's back in the sky, and we're going through this process where it condenses, precipitates, rain falls. We have percolation where it goes through the ground, it runs down we have runoff, which runs down into streams and rivers. And then we have animals and plants taking up the water and evaporating it, as well as the ocean evaporating it. Okay? Now, all of these are part of the water cycle, a process that not only gives us water to drink and food to eat, but it also helps with the weather patterns that help grow our crops. Okay, water conservation. So here's the deal, okay, is that when we talk about the water cycle, we also have to talk about ways that humans have disrupted the water cycle. Like, for example, chemical waste from factories is dumped into rivers and lakes, or it's dumped straight into the ground, which then can seep into our groundwater. Like chemical leaks, like gas leaks and stuff like that, because we store gas underground in storage tanks. Sometimes if those things leak, they can go straight into our groundwater, which contaminates the water that we can drink that's supposed to be clean and pure and good for us to drink. Okay, sometimes we have oil spills that contaminate our oceans and destroy our animal life in there. Pesticides and fertilizer on farms enter the surface water and the groundwater in large quantities. So when people put pesticides and fertilizer on their farmland, and it rains and all that water gets run off, okay, that stuff ends up in our groundwater, the pesticides and the fertilizer. If it percolates through the ground, water can still carry some of those artificial chemical compounds because they don't get removed by the stone. They can persist in water despite that natural filtration system. So sewage, okay, we dump stuff down our bathroom drains, and that's dumped in our oceans. So sewage and stuff dumped down your bathroom drains are dumped in our oceans, and in large quantities, that removes the amount of oxygen we have in the water because that sewage can really use up the oxygen. And so what happens is we get this thing called a dead zone. It's basically where there's too little oxygen and the water can't support sea life, so all the animals and plants die there. There are more than 400 zones around the world. Right now, there's about 405. So there's a lot of places around the world where, because we're dumping sewage, we're literally destroying all life that lives in that area. Acid rain is a situation where basically compounds are released by burning fossil fuels, right? And when they mix with water and that water comes down to earth during precipitation, that water pollutes the ground and it pollutes the water. And basically plants can't grow in that soil because it's too acidic. And sometimes, like you can see in the picture, like fish can die. It like literally changes the chemical composition of the soil or the water. And it takes eons to repair this kind of damage, like thousands of years for this kind of stuff to get fixed. In addition to dumping our trash and our waste in landfills, we also dump it into the ocean, and that hurts sea life of all kinds. So our plastic waste and our, just general waste, like all of it, like it can destroy animals. Like they try to eat it because they think it's food, and then they end up with like bellies full of trash. It's really gross and horrible. And once a pollutant is in our water supply, it's really hard to get rid of it because some pollutants break down into harmless chemicals, right? And that's fine, but others are toxic. And, that means that we're drinking toxic water, and, animals are drinking toxic water, and plants are drinking toxic water. And if we eat those animals or plants, then we're eating more toxic stuff. If we stop putting pollutants into the water, then that pollutant travels downstream and it's replaced by unpolluted water. But it takes a really long time to clean water this way. Like it's not just gone, it's actually just diluted. So it doesn't have as much of an impact, but it's still there. All right, so I'm going to run out of time, so I'm actually going to come back after a quick break. And so you can just hop to the next video.